So we'll begin our exam review with the trigonometry and angle property unit that we started with. So this was unit 1. I think if you're looking at your exam review sheets, it says day 5 or unit 5, sorry. But we did this unit first, actually. So first thing we want to look at are the rules. If the angles A and B add up to 90 degrees, we call them complementary angles. If the angles A and B add up to 180, they make a straight line. We call them supplementary. If the angles form this X pattern and they're directly across from each other, or these two angles, they're vertically opposite and they are equal. Then we have corresponding angles. Sometimes you refer to that as the F pattern, but corresponding angles are equal as well. So these angles right here, if you had an X here, X down here as well. Then we had alt interior. So remember, when you're looking at these, it's important to be able to label the parts. The blue lines in each of these figures represent the parallel lines. They're not parallel here, I guess. But for corresponding, alternate, and co, they are the blue lines. They're parallel. They never touch. They have the same slope. The black line is called the transversal. If your angles are inside the parallel lines, we call them interior angles. And if your angles are outside the parallel lines, we call them exterior angles. Corresponding angles are equal. Alternate angles are equal. It doesn't matter if they're interior or exterior. And then the co-interior angles, okay, those add up to 180. They are supplementary. Same thing with the co-exterior angles. They add up to 180. All right, how did we use those to help us solve problems? Well, you were given problems like this, and this is the first one in your handout. Let's compare all of these angles to this one right here, the 105 degrees. Does anyone know what X would equal and Y it would equal? X would equal 105 degrees because it's what? What relationship is it with the 105? It's vertically opposite, wicked. Let's compare all of the other angles, Y and Z, the ones that we're looking for, with 105. What could you say about the Y? It's 75 degrees. How'd you get that? Okay, he knows that Y, so he's saying this, Y equals 75 degrees. And he said 180 minus 105. He knows that Y plus 105, here's the math, must add up to 180 degrees because they form a straight line. What are they called? What's that rule? If they add up to 180 degrees, look back here. They're supplementary. That's right. So supplementary. And I think it's with an E. But here's why it would equal 75. If you know that Y plus 105 equals 180, and you wanted to get Y by itself, you would subtract 105 from both sides. Or you'd move the positive 105 from the left to the right. There's your 75 degrees. Anyone know what Z equals? Compared to the 105. There's your parallel lines. There's the transversal. Look at those angles, 105 and Z. Are they inside the parallel lines or outside the parallel lines? Inside. So I know they're interior angles. Are they alt interior angles or are they co-interior angles? Alternate. In order for them to be co-interior, they'd have to be on the same side of the transversal. So what would Z equal? Anyone know what Z would equal? 105. because alternate interior angles are equal. So I would call this alternate interior. And that was the first type of question we looked at early on in this course, after we learned our rules. So the x and the 105 were vertically opposite. The y and the 105 added to give me 180. They were supplementary. And the z and the 105 were alternate interior angles. All right, let's flip over and look at the next example. It says solve for x and solve for y. I'm going to take it one step further and say, then solve for the indicated angle. And you should have these in your notes. So let's focus on the x's first. So I'm going to just block all this stuff out of the way. Look at the x plus 23 and the 52. So this is a parallel line 1. This is parallel line number 2. Are my angles interior or exterior? Are they inside the parallel lines? No, they're exterior angles. So this is exterior, and so is this. What's the word for the purple line? Starts with a T. It's the transversal. So what's the relationship between x plus 23 and 52? I know they're exterior angles, but they're also on the same side of the transversal. Which one? It's co-exterior angles. And what do you know about co-exterior angles if you look back here? They add to 180. Remember when we were doing these, I always told you to write down your first angle and write down your second angle. And you have a choice to make. Okay? They're either equal to each other, or you can add them together and they would equal 180 degrees. Sometimes you can add them together and they'd equal 90 degrees, but there's no complementary angles here. There's no right angles shown. And do we agree that since they are co-exterior, they should add to 180 degrees? How would you solve this? Group your like terms, 23 and 55, or sorry, 52. 75 degrees. I just added those together. And then what should you do to get x by itself? Subtract 75 degrees from both sides. And what's 180 minus 75? X equals 105 degrees. So if I know what x is, solve that part. How would you figure out what this angle is? We'll call it angle 1. I would fill a 105 in for x and add 23. Angle 2, I know what it is. It's just 52. But to get angle 1, I'm going to go x plus 23 degrees. And I'm going to fill this right in here. What is 105 plus 23? It's 128 degrees. And if you added 52 to that, 128 plus 52 gives you 180. They are supplementary angles. Everyone cool with that? Next move is to find y. How do I find y? I got to come up with a relationship for these two angles. I'll call this angle 3, and this one, angle 4. So it's still line 1, line 2, but this time we have this one as the transversal. Are they interior angles or exterior angles? This is an exterior angle, so is this one. How do I know that? Because they're outside the two red parallel lines. Are they on the same side of the transversal? No, so they cannot be co-exterior. What other type of exterior angle do you have? Alternate exterior angles. Okay, so these ones were co-exterior. These ones are alternate exterior. What do you know about alternate exterior angles? They're equal. So in this case, I'm going to take the angle 3, 3y minus 1 degree, and I'm going to take angle 4, 2y plus 41 degrees, and I'm going to set them equal to each other. They don't add to 180. They are equal because they're alternate exterior. What would you do in this case? I'd have to group my like terms. So I'm going to bring the 2y from the right to the left, and I'm going to bring the negative 1 from the left to the right. So the 2y comes over this side, becomes a negative 2y. The negative 1 goes to the right and becomes a positive 1. Or you could subtract 2y from both sides and add 1 degree to both sides. What's 3y minus 2y? 1 what? Or just y? What's 41 degrees plus 1 degree? Okay, so I know y is 42 degrees. That's great. Now let's find the indicated angle. What's angle 3? Well, angle 3 says 3y plus 23 degrees. I am going to fill a 42 in for y. So it will say 3 times 42 plus 23 degrees. 3 40s are 120, and 6 more, that gives me 126 plus 23 degrees. Add those together, and I get 149 degrees. Where am I getting the what? 23. It shouldn't say 23. What should it say? 3y minus what? Have no idea where I got the 23 from, guys. So, if I write a minus 1 degree, oh, I was looking over here. The 23 in the other one. What's 126 minus 1? 125 degrees. So that's what angle 3 equals. How do I figure out angle 4? 2y plus 41. What should it equal? It should be the same. Okay? So if I fill the 42 in for this y, and I go 2 times 42, and then add 41. 2 42s are 84 plus 41. There's another 125 degrees. Both are equal. So I solve for x and the indicated angles. I solve for y and the indicated angles. You okay with that? The next type of question we discussed, we get into our trig ratios, our 3 primary trig ratios: sine, cosine, and tangent. Does anyone remember what the sine of theta was equal to? It's the opposite side over the hypotenuse. Cosine theta is the adjacent side over the hypotenuse, and tangent theta is the opposite side over the adjacent side. Yes. Yeah, you'll have a formula sheet, and those will be included on your formula sheet. Cool. With all of your conversions and your simple interest formula and your compound interest formula and the volume of all your cylinders and cones and pyramids and prisms and the area of all of those figures as well. Cool? All right. When it comes to labeling the triangle, the side that is across from the right angle, the longest side is your hypotenuse. If you can find theta and move directly across, that's your opposite side. And what do you call this side down here, the base of the triangle? Next to or beside theta is the adjacent side. Everyone okay with labeling the triangle? That's the order we did it. Really doesn't matter what order you label them in. I like to go in that order just to be consistent. In order to do part A, in order to find theta, that's this angle down here, which trig ratio would I use? Why would I use this one? I have the adjacent side and I have the hypotenuse. Okay? I don't know what the opposite side is yet. I'm not concerned with that right now. I know that the adjacent side is 9 and I know the hypotenuse is 13. Cosine is the trig ratio that uses the adjacent and hypotenuse. So I would start by writing down that formula. Cosine theta equals the adjacent over the hypotenuse. And then I would fill in the information I know. How long is the adjacent side? It's 9 units long. How long is the hypotenuse? 13. Do you remember what we did from there? We converted 9/13 to a decimal. What is 9 divided by 13? It's 0.6923. And it says 0.7692. We were going 4 decimal places. What did I do from here to get theta? I can't divide both sides by the word cosine. That doesn't make sense. What do we call that? The inverse cosine. So I'm going to do second function cosine and then 0.6923. If you have a backwards calculator, you have the 0.6923 in your calculator, just hit second function cosine. And I'm getting theta equal to 46.1875 degrees. Sometimes the textbook or the questions will say round to the nearest degree, so I'd call it 46 degrees, or round to the nearest tenth, 46.2 degrees. Cool? You can even do the following. You could, from here, say that theta is equal to the inverse cosine of, just make sure you put the 9/13 in brackets. Second function cosine, 9 divided by 13. There's my 46.18. Now it's a little different because the 9/13 isn't rounded to 4 decimal places. It's 46.18693854. If I don't round, more accurate. And I would accept either of these answers. Cool? How do you do part B? How do I find the missing side? How do I find x? C squared minus b squared equals a squared. Okay, or you could just go with the regular Pythagorean theorem. A squared plus b squared equals c squared. What do I have to fill in for c? Which side goes there? 13, the hypotenuse. The longest side would go here. Does it matter which one I fill in, A or B? The legs of the triangle? No. You okay with me calling A the adjacent side? If I do that, I'm going to fill a 9 in there, and I'll fill an X in for B. So the X will go here, and a 9 will go here. If I work this out, I go 81, 9 times 9, plus X squared equals 169. That's 13 times 13. In the next line, I will subtract 81 from both sides. 169 minus 81 gives me 88. I'll take the square root of both sides, and I'll get the square root of 88 to be 9.3808. Now, that's not degrees. That would be the units of measurement that the side lengths are measured in. It could be centimeters, millimeters, meters, kilometers, whatever. And really, this could be a plus or a minus, but the only one that makes sense in this situation is a positive answer. So I've got 9.3808 and 46.1875 degrees, or 46.1869 degrees. And the last example I want to go over with you is a word problem. Okay? And the word problem talks about the angle of elevation or the angle of depression. And it's one of the situations where there is like two triangles in play or at work, and you're looking for the distance, I think, between the two swimmers. You had a question similar to this on your test. You will have a question like this on the exam. Okay? So here's the question. What did we always do with this word right here? The angle of depression. Changed it to elevation. Okay, so rather than, in this case, the lifeguard looking down at the two struggling swimmers, think of if the struggling swimmers were looking up at the lifeguard. And the angles are the same. The angle of elevation is equal to the angle of depression because they are alternate interior angles. All right. First thing you should do is draw a picture. Do you have this picture drawn for you? It's there on your sheet. Okay. The 7 meters represents the height of the lifeguard. That's the height of the stand or the tower they're sitting in. This is swimmer 1. This is swimmer 2. The biggest angle, 50 degrees, is always closer to the chair. The 36, that's the angle that's farther out. I think if you look at the pictures, you can tell that this angle is bigger than this one. Now, the next thing you have to do is come up with some variables. I'm letting x equal the total distance. So that would be the distance from the base of the chair out to the second swimmer, the farthest swimmer. And I'm saying let y equal the distance from the base of the chair to this closest swimmer. What do we actually want to find? The distance between them. We want to know this. We want to know z. So the first thing you need to do is break it up into two individual triangles. Look at the red triangle. That's the big one, with a base of x, a height of 7, and an angle of 36. And to find y, I could use the smaller blue triangle. It's got a base of y, a height of 7 as well, but the angle's different. In order to solve for x and y, I have to use one of my trig ratios. Well, let's label the triangles so that we can figure out which trig ratio to use. This is the hypotenuse. Over here, there's nothing. I don't have a variable or a known value. So I'm not going to use the hypotenuse. So right away, that should tell you that sine theta and cosine theta are no good to you. What would this side be? The 7. It's the opposite. And this would be the adjacent, x. Which trig ratio uses the opposite and adjacent sides? Tangent. So I am going to start by writing down tangent theta equals the opposite over the adjacent. What can I fill in for theta? What's the angle in this case? That's 36 degrees. It's going to equal, what's the opposite side? 7 divided by the adjacent side, x. We cool with that? Now, this is not the inverse tangent, it's just the tangent of 36. So take your calculator, tangent 36, write it down 4 decimal places, 0.7265 equals 7 divided by x. And then what would you do from here? This kind of leads us into our next unit, which I'll show a video on tomorrow. What did we do? Cross multiply. Okay, or you can multiply both sides by x. Same thing. If I cross multiply, I'm going to get 0.7265, and I'll stick an x after it. Write your equal sign, and then multiply the 1 and the 7. 1 times 7 is 7. And what would you do from there? I don't want to know what 0.7265 times x is. I just want 1x. I divide both sides by 0.7265. Whatever you do to the left, you do to the right. Those would go away. It would leave an x on the left. 7 divided by 0.7265 equals 9.6352. And what would the units on that be? It's meters. It's the same as this distance. So that's the total distance out to the second or the farthest swimmer. So knowing that, when I solve for y, should I get a bigger answer or a smaller answer? If x is 9.6, look at y. Should be smaller. How do I solve for y? I do the same steps. I don't have the hypotenuse. I know that 7 is the opposite side. I'm going to use the opposite side. And I know that y is the adjacent side. And I know my angle, theta, is 50 degrees. I use the exact same formula. Tangent theta, opposite over adjacent. What do I fill in for theta this time? What's the angle in this triangle? 50 degrees. It equals the opposite side, which is a 7, over the adjacent side, which is a y. That's why you need to label it. Figure out the tangent of 50 degrees. The tangent of 50 degrees is 1.1918. That's equal to 7 divided by y. I'm going to drop a 1 under this, and I'm going to cross multiply. 1.1918 times y is 1.1918y. Write your equal sign. 1 times 7 is 7. And then divide both sides by 1.1918. These would go away. It would leave a y on the left. And 7 divided by 1.1918 gives me 5.8735. And that's meters. So that's what x is, and that's what y is. I know those two values. How do I find z? Add them together. Let's think about that for a second. If I add x and y, I'm going to get something that's bigger than x, so it's definitely bigger than z. Which two letters add up to give you the other? Y and z would add together to give x. So if I write that down, y plus z equals x, and I rearrange to get z by itself, I'd have the following. Z is equal to x minus y. Here's where I take the 9.6352, the larger value, and I subtract the smaller value, 5.8735. And that's going to leave me with z, which is the total distance, 9.6352, the total distance between the two swimmers, minus 5.8735. I get 3.7617. And I would say the swimmers are 3.7617 meters apart. Now, rather than trying to figure out how far apart they are, I probably should just jump in and save them. But that is a review of your trigonometry and your angle properties of parallel lines section, chapter 1.